Hi everyone, how are you? Welcome back Murari Maths online classes. Today we discuss about determinants JEE Mains problems. Okay, now explain a statement. In this statement, what is given? A is 3 by 3 matrix such that det of A value 4 given. Then find out det of adjoint of A whole inverse. Okay, det of A inverse is nothing but det A whole inverse. So here adjoint of A is one of the matrix. So det of adjoint of A whole inverse is nothing but det of adjoint A whole inverse. So det of adjoint of A is nothing but constant. This is constant. That is always constant. Constant power minus 1 is nothing but 1 by constant. 1 by det of adjoint of A. Like 5 power minus 1 is equal to 1 by 5. So det of adjoint of A whole inverse is equal to 1 by det of adjoint of A. So det of adjoint of A, we have one formula det A power n minus 1. But n value here how much value? This is 3 by 3 matrix, n is equal to 3. So det A value from statement, this value given 4. Now substitute these two values in this final answer. Det of A value 4 to the power 3 minus 1. What we get here? 1 by 16. Okay, now I am going to explain next problem. In the statement, the product of the matrix B with a matrix A has inverse of C given. The product of B and A is equal to inverse of C means C inverse given. So BA is equal to C inverse given. Then find out A inverse. So from this equation, find out first A matrix. Now pre-multiply B inverse on both sides. What we get here? B inverse BA is equal to B inverse C inverse. B inverse B value, how much value? B inverse B is equal to I, unit matrix. I into A is equal to B inverse C inverse. So I into A value, how much value? A. So A is equal to B inverse C inverse. What is required here? A inverse is required. Okay, now, so required is A inverse. A value already we have got it. B inverse C inverse. B inverse C inverse whole inverse. Okay, we have one formula xy whole inverse is equal to y inverse into x inverse. Now we should apply formula. This is here x value B inverse, y value C inverse. Now we should apply same formula. What we get here? Y inverse, C inverse whole inverse. This is y inverse. X inverse, here x value B inverse whole inverse. What we get here? CB. C inverse whole inverse is nothing but C. B inverse whole inverse is nothing but B. Okay. Now, A inverse we get CB. From statement CB, two matrices are given. Direct to multiplication. C into B. Therefore, A inverse is equal to CB. What is the C given here? Minus 1, 0, 1, 1, 1, 3, 2, 0, 2 into B matrix. What is given here? 2, 6, 4, 1, 0, 1, minus 1, 1, minus 1. After multiplication, what we get here? Minus 3, minus 5, minus 5, 0, 9, 2, 2, 14, 6. Okay, now I'm going to explain next problem. In the statement P matrix is given, is adjoint of 3 by 3 matrix A. So P is what is given? P is equal to adjoint of A given. Then and that A value 4 given, then find out alpha value. So now taking delta on both sides, what we get, delta of P is equal to delta of adjoint of A. Delta of adjoint of A, we have formula delta A power n minus 1. So delta P, here already P matrix from statement given, delta of P 1 alpha 3, 1 3 3, 2 4 4 is equal to delta of A value from statement, what is given, 4 4 to the power n value, how much value, n is equal to order of the matrix 3 here. This is n by n square matrix, n is equal how much value, 3. 4 to the power 3 minus 1. So it will going to be plus minus plus. So 1 into 0 minus alpha into 4 minus 6 plus 3 times of 4 minus 6 is equal to how much value, 16. Here minus plus 2 alpha, this is minus 6 is equal 16. 2 alpha we get the 22, alpha value we get 11. What is answer? 11 is answer. Okay, now explain next problem. In the statement, A is orthogonal matrix of order 3 given. Then find out adjoint of delta of adjoint of 2A. First find out adjoint of 2A value. So we have adjoint of Ka is equal to, what is the formula? K to the power n minus 1 into adjoint of A. Here, what is our target? Delta of adjoint of 2A. So delta of adjoint of here K value, how much value? 2. Now we should apply this formula, K to the power n minus 1, 2 to the power n minus 1. N value, how much value here? N is equal to order 3. So 2 to the power 3 minus 1 into adjoint of A. Here this formula used. So delta of, this is 2 square is 4 times of adjoint of A. Okay, we have one more formula, delta of K into A is equal to K to the power n into delta of A. Here n is order of the matrix. So here K value placed in 4 given. Okay, now we should apply delta of Ka formula, K to the power n, 4 to the power n into delta of adjoint of A. But here n value, how much value? 3. 4 to the power 3. Delta of adjoint of A, we have one formula. Delta of adjoint of A is equal to delta A power n minus 1. So delta A power n minus 1, n value 3, 3 minus 1 is 64 into delta A value, how much value? Here in the statement, A is orthogonal matrix is given delta A value plus or minus 1. So if A is orthogonal matrix, then delta of A value plus or minus 1, here plus or minus 1 whole square. What we get here? 64. 64 into plus or minus 1 whole square, plus or minus 1 whole square, we get plus. So answer is 64. Okay, now explain next statement. In the statement, A is orthogonal matrix given, then find out A inverse. Okay, we have, what is the definition of orthogonal matrix? A into transpose of A is equal to I. Okay, that implies what is required? A inverse is required. So transpose of A is equal to, we get A inverse. Okay, we have one formula AB. If AB is equal to, if AB is equal to I, that implies B is equal to A inverse. In the place of B here, what is there? A transpose is there. So transpose of A is equal to what we get? A inverse is A inverse. We have got it. What is the answer here? A inverse is equal to, answer is the transpose of A. Okay, now explain next statement. In the statement, the value of third order, that is 11. So delta of A is equal to 11 given. Here n is equal how much value? 3. The value of the square of the debt formed by the cofactors. So what is required? Here required is debt of cofactor matrix whole square. Okay, we have debt of cofactor matrix is equal to debt of cofactor matrix whole transpose. Both are equal in debt. What is the formula? Debt of A is equal to debt of transpose of A. Okay, debt of cofactor matrix is equal to debt of transpose of cofactor matrix. Both are equal. Okay, debt of transpose of cofactor matrix is nothing but adjoint of A. Debt of adjoint of A, this is nothing but. Debt of cofactor matrix is nothing but debt of adjoint of A whole square. Okay, we have debt of adjoint of A, one formula, debt A power n minus 1. If debt A value here, what is given? 11 given. 11 to the power n value, how much worth? 3 minus 1. N value 3, 3 minus 1. What we get here? 11 square is 121. So debt of adjoint of A, we have got 121, 121 whole square. So 121 whole square is equal how much value? 1464. Okay, next I am going to explain next problem. So in the statement debt to A not equal to 0, A into adjoint of A how much? A into adjoint of A is nothing but debt to A into I. That one formula is there. What is the formula? A into adjoint of A is equal to adjoint of A into A is equal to debt A into I. Very, very important formula, this one. Okay, now explain next problem. Here in this statement, debt of log E square, log E cube, and so on, log E to the power 5 value, how much value? So we have one formula in logarithm. Log of A to the power M is nothing but M log A. Here power M taking before logarithm, one property is there. Log of A to the power M, we have M log A. Okay, now we should apply this for property log E value. Log E nothing but log E base C. Log E base C value, how much value? 1. Log E square. Log E square is nothing but 2 times of log E. Log E value 1. The log E base C value 1. Okay, what is the log A base B? We have one formula. Log A base B is equal to log A by log B. Log E base C is log E by log E. Get cancel. What we get here? 1. So 2 log E cube. Log E cube is nothing but 3 log E 3. Log E square 2, log E cube 3, 3, 2, 3, 4, 3, 4, 5. Here plus, minus, plus. Now we should apply that process 1 into 15 minus 16 minus 2 times of 2 present in here first row, second column. After deleting first row, second column, 10 minus that value 10 minus 2 5 is 10, 3 4 is 12 plus 3 times of here 8 minus 9. What we get here? This is minus 1. This is plus 4. 3 into minus 1 also will be 0. Okay, now I am going to explain next problem. Here in the statement, debt of 3 by 3 matrix not equal to 0 given, then find out A square adjoint of A. A square adjoint of A is equal to A into A adjoint of A. A into adjoint of A, we have one formula, debt A into I. What is the answer? A into debt A. So A into I value, how much value? Since A into I is equal to A. So what is the answer? A into that A answer. So A is the one of the matrix, that A value is one scalar. So A times of that A answer. Okay, now explain next problem. In the statement A is orthogonal matrix given of order 3, then find out that of adjoint of 2A. Okay, we have one formula, adjoint of Ka. Adjoint of Ka, we have formula K to the power n minus 1 into adjoint of A. ఏమో క్లాస్ చెప్తాను మధ్యలో ఫోన్ చేశారు. Okay, now I'm going to explain next problem. In the statement, adjoint of this matrix is equal to 5A minus 2, 1, 1, 0, minus 2, minus 2B, 1, 3 by 3 matrix is given, then find out AB values. How to find this value? How to find AB values? Okay, now taking transpose on both sides, what we get? Now taking transpose on both sides. So adjoint of 1, 0, 2, minus 1, 1, minus 2, 0, 2, 1 whole transpose is equal to 5A minus 2, 1, 1, 0, minus 2, minus 2B whole transpose. So adjoint of A whole transpose is equal to what is the cofactor matrix? What is adjoint of A? Adjoint of A is nothing but transpose of cofactor matrix. Adjoint of A is equal to cofactor matrix whole transpose. So adjoint taking transpose on both sides, what we get here? Adjoint of A whole transpose is equal to cofactor matrix whole transpose how much value? Cofactor matrix. So okay, we have one formula A transpose whole transpose, we get A. So cofactor matrix whole transpose what we get? Cofactor matrix. So adjoint of A whole transpose is nothing but cofactor matrix. Cofactor matrix of 1, 0, 2, minus 1, 1, minus 2, 0, 2, 1 is equal to its transpose, right side transpose is 5, 1, minus 2, A 1, minus 2, minus 2, 0, B. Here what are target? AB values. Here AB. A is nothing but cofactor of A. Here cofactor of A here after deleting first row or second row, first column. A present in here, second row, first column. After deleting second row, first column, A is equal to minus 1 power, second row, first column, 2 plus 1, I plus J formula into minor, 0, 2, 2, 1. What we get here? Minus 1 power 3, minus of AD minus BC formula, 0 minus 4, we get 4. So A value we get 4. Now I am going to explain B value. Here B. Here what is the B? B is the third row, third column element. Here minus 1 power 3 plus 3. Here B is the third row, third column element. Here is equal to B cofactor. The element of B cofactor is after deleting here. Now after deleting third row, third column. Okay, minus 1 power 3 plus 3. The P present in 3 plus 3. 3 plus 3 means third row, third column. After deleting third row, third column, what we get here? 1, 0, minus 1, 1. What we get? Minus 1 power even number is plus. AD minus BC is 1. So what are answers? A value 4, B value 1. The answer is 4, 1. Okay, now explain a statement. In the statement, AB2 matrix is 3 by 3 given. So as well as two conditions Aij Aij plus Aji is equal to 0, comma Bij minus Bji is equal to 0 given. Then A to the power 4 into B cube. Option 1 singular matrix, option 2 non-singular matrix, option 3 zero matrix, option 4 skew symmetric matrix. Okay, what is the here given condition Aij? If plus Aji sending right side, what we get? Minus Aji. This is definition of skew symmetric. So transpose of A is equal to minus A. Here A is skew symmetric matrix. So skew symmetric matrix that of skew symmetric matrix of odd order is equal to how much value? 0. The 3 by 3 is odd order, so that will be 0. So therefore that of A is equal to 0. Next, what is the second condition here given? Bij is equal to minus Bji sending right side, what we get? Plus Bji. This is definition of symmetric matrix. So transpose of B is equal to B. Here B is symmetric matrix. Okay, here what is required? A to the power 4. Let A to the power 4 into B cube. Now taking det on both sides, let us take A to the power 4 into B cube is equal to X. Now let us take det on both sides. Det of X is equal to det of A to the power 4, det of B whole cube. Det of A value we have got 0. 0 into det B value. So det B whole cube, right? 0 into anything is 0. Therefore, det of X is equal to 0. Therefore, X is singular matrix. X is nothing but statement A to the power 4 into B cube is singular matrix. First option correct. Okay, now I am going to explain next problem. In the statement, Aij plus Aji is equal to 0. Bij minus Bji is equal to 0 given. Where AB are 3 by 3 matrices, then find out A to the power 4 B cube value. A to the power 4 B cube is, the first option is singular matrix, second option is non-singular matrix. So third option is unit matrix, fourth option is scalar matrix. Here from statement, what is given? Aij is plus Aji is equal to 0. Aij is equal to minus Aji. This is the definition of skew symmetric matrix. The transpose of A is equal to minus A. So that of skew symmetric matrix. That of skew symmetric matrix of odd order is equal to how much value? 0. The 3 by 3, this is the odd order. So that of skew symmetric matrix of odd order is equal to 0. So here that of A value we get 0. Why? Because here A is skew symmetric matrix. Next, what is the second condition given? Bij minus Bji is equal to 0. That implies Bij is equal to Bji. Bji. This is the definition of symmetric. Symmetric. So transpose of B is equal to B. Here B is a symmetric matrix. Okay, now what is here given required? A to the power 4 into B cube. Okay, let us find det value. Let us take det of A to the power 4 into B cube. It will going to be det A power 4 into det B whole cube. So det A value, how much value? 0. Why? Because odd order of skew symmetric matrix of odd order is equal to skew symmetric matrix of odd order is equal to 0. This is 0 times of that of B cube. It will going to be 0. Therefore, a to the power 4 B cube, that value 0 means a to the power 4 B cube is singular matrix. Okay, now explain next problem. Here in the statement that of log e square log of e to the power 3 and so on given. Okay, we have one formula a to the power log m base a is equal to m. Okay, as well as one formula a to the power log of a to the power m is equal to m log a. Okay, now we should apply this formula. The power taking before logarithm. Power taking before logarithm, what we get here is equal to log of okay, now explain next statement. In the statement matrix A given as well as that of adjoint of A 23 power 4 given, then find out U value. So what is given condition here? That of adjoint of A given, what is given 23 power 4. Okay, we have one formula that of adjoint of A. Formula is that A power n minus 1 whole square is equal to 23 power 4. But here n value how much value? This is 3 by 3 matrix. N is equal to 3. Okay, now write substitute that A power n minus 1. 3 minus 1 whole square is equal to 23 power 4. That implies that A power 4 is equal to 23 power 4. Okay, here that of A value how much value here? Therefore, data of A value we have got a 23. So data of A value from statement given U2 minus 1, minus 1, 1, 2, 2 minus 1, 1 is equal to 23. We have got it plus minus plus. According to that, you will find it. This value, how much value? 3U plus 11 is that value is equal to 23. Therefore, 3U is equal to 23 minus 11. It will going to be 12. Therefore, we get 12 by 3 is equal to 4. What is answer here? 4 answer. Okay, now explain next statement. In the statement A 2 by 2 matrix is given 2 minus 1 0 2. One matrix B given I minus 5C1 adjoint of A 5C plus 5C2 adjoint of A whole square minus 5C5 adjoint of A to the power 5. What is required here? The sum of all elements of the matrix B. So B is equal to what is given right here? 5 I minus 5C1 adjoint of A plus 5C2 adjoint of A whole square minus plus or minus alternate terms here there and so on minus 5C5 adjoint of A to the power 5. Here this expansion can be written as 1 binomial theorem expansion is there. Okay, we have x minus y to the power n is equal to NC naught x to the power n minus 0 y to the power 0 minus NC1 x to the power n minus 1 y to the power 1 plus NC2 x to the power n minus 2 y to the power 2 minus and so on minus 1 to the power n into NCn into x to the power n into y to the power n, x to the power n minus n into y to the power n. Here, on comparing this formula, B is equal to I can be written as here 5C1, 5C2, like up to 5C5 is there. What is the first term here? There 5C naught. 5C naught I to the power 5 minus 0 into y. Here y value, how much value there? Adjoint of A given. So y square, y cube and y to the power 5 here. So here y place and right adjoint of A power 0. 5C naught value 1. I to the power 5. I to the power n is equal to I, where n belongs to any natural number. So I to the power 5 is also I into adjoint of A power 0 value, anything power 0 value 1. This is 1. This is I to the power 5 is I. 5C naught is 1. What we get here? 5I. Here I can be written as 5C naught into I to the power 5 minus 0 into adjoint of A power 0. Next 5C1 into I to the power 5 minus 1 is 4. Adjoint of A power 1. 5C1 value 5. I to the power 4 value I into adjoint of A, adjoint of A. So 5C1 adjoint of A here, so written as 5C1 into I to the power 4 into adjoint of A plus 5C2 into I to the power 5 minus 2. N minus 2. 5 minus 2 means 3 into adjoint of A whole square and so on. Last term is 5C5 I to the power 5 minus 5 0 adjoint of A to the power 5. Here x is equal to I, y is equal to adjoint of A, n is equal to 5. Direct substitute in formula. So b is equal to what we get? X minus y power n. So now I can say that x place and right I, y place and right adjoint of A to the power 5. Okay, here I from I is unit matrix 1 0 0 1 minus adjoint of A. From statement A matrix is given. What is A matrix is given? A is equal to 2 minus 1 0 2. Adjoint of A value. So adjoint of A is equal to transpose of cofactor matrix. One shortcut method is there. What is the method here? First, we should interchange principal diagonal elements. 2, 2 will be 2, 2. Other diagonals multiply with 1 minus sign. Minus 1 will be plus 1, 0 will be 0. Here write 2, 1, 0, 2. Whole to the power 5. Okay, now this continuation. Therefore, B is equal to what we get here? 1, 0, 0, 1 minus 2, 1, 0, 2 whole to the power 5. The subtraction of these two matrices, what we get here? 1 minus 2 minus 1, minus 1, 0, minus 1 to the power 5. It will going to be B is equal to minus 1, 0, minus 1 whole square into minus 1, 0, minus 1 whole cube. Okay, here after simplification, we get minus 1, minus 5, 0, minus 1. What is required? The required is the sum of all elements of the matrix B is equal to minus 1, minus 5, 0, minus 1. What we get here answer? Minus 7. Okay, now explain next question. In the statement A1, A2, A3, ANR and GP given, then find out delta value. Here, 2, 4, 8, I give one example, 2, 4, 8 are in GP. So 2 is nothing but 4 is 2 square, 8 is 2 cube. Are in GP. Log 2 square, log 2 cube. So in logarithm values are in AP. Why? Because here log 2 is first term. Log 2 square is nothing but 2 log 2. The power taking before logarithm. Log 2 cube is nothing but 3 log 2. Are in AP. Why? Because here common difference equal. 2 log 2 minus log 2 value log 2. 3 log 2 minus 2 log 2 value log 2. If ABC are in GP, ABC are in GP, log A, log B, log C are in AP. The logarithm values are in AP, arithmetic progression. Okay, here A1, A2, A3, AN are in GP. So log AN, log A1, log A2, log A3, in logarithm values are in AP. Therefore, log of A1, log of A2, log of A3 and so on, log of AN are in AP, arithmetic progression. Here log AN, let us take log AN is equal to A. Delta is equal to log AN, let us take A. Log AN, log AN plus 1, log AN plus 2, log AN plus 3, log AN plus 4, log AN plus 5, log AN plus 6, log AN plus 7, log AN plus 8 are in AP. Let us take log AN is A. Log AN plus 1, next term is A plus D. Next term is A plus 2D. Here A plus 2D. Here A plus 3D. Here A plus 4D. Here A plus 5D. Here A plus 6D. Here A plus 7D. Okay. Here, how to solve this problem? This is C1, column 1, column 2, column 3. So column 2 replaced by, here I will use one operation. C2 replaced by C2 minus C1. Next, C3 replaced by C3 minus C1. What we get? Tell me here. C2 minus C1. C1 right as it is A plus 2D, A plus 5D. C2 minus C1 is D, here D, here D. C3 minus C1, 2D, here 2D. A plus 4D minus A plus 2D is 2D. A plus 7D minus A plus 5D is 2D. Here, second column elements, third column elements are proportional. So that will be 0. That will be 0. Answer is 0. Okay, now explain next statement. In the statement, what is given? Det of 1 by 81 into adjoint of 2 adjoint of 3a. Okay, we have one formula. Adjoint of Ka is equal to K to the power n minus 1 into adjoint of A. Okay, first now we should apply this formula adjoint of K. Here K value, how much value here? 3. So this is equal to that of 1 by 81 times of adjoint of 2 times of, here we should apply this formula K to the power n minus 1. Here K value, how much value? 3. 3 to the power n minus 1. Here n how much value given here? N is equal 3 by 3 matrix is given here. From statement A is 3 by 3 matrix is given. So 3 to the power 3 minus 1. 3 minus 1 into adjoint of A. This is equal to 1 by 81 times of adjoint of this is 9 to the 18. Adjoint of 18 times of adjoint of A. Again, now we should apply the same formula. K value 18. Adjoint of A plus adjoint of A here there. Okay, 1 by that of 1 by 81 times of, according to this formula, right, K value 18, 18 to the power n value 3, n is the order of the matrix, into adjoint of A. So it will going to be 18 power 3 minus 1 into adjoint of, the inside matrix A is adjoint of A. So 18 to the power 3 minus 1 into here adjoint of A, adjoint of A. So what we get here 1 by 81. Why 81 can be written as 3 to the power 4 into 18 power 2. 18 into 18. 18 into 18 can be written as 9 square into 2 square. Here 9 square 3 to the power 4 get cancelled. Into adjoint of A. Okay, we have one formula, det of Ka is equal to K to the power n into det of A. Here A, let us take adjoint of A. The K value, how much value? 4. Okay, now applying formula K to the power n. 4 to the power 2 square value 4. 4 to the power n. N value, how much value? 3. Into adjoint of A. Okay, that of K times of adjoint of A. This should take A. That of Ka, we have formula K to the power n into that A. K to the power n means 4 to the power n value, how much value here? N is equal to order of the matrix is 3. 4 to the power 3 into that of adjoint of A. Okay, we have one formula. That of adjoint of A is equal to, we have formula that A power n minus 1 whole square. Okay. So here 4 cube, 64 into, therefore 64 into that of adjoint of A. So 64 times of that of adjoint of A, we have formula that A power n minus 1 whole square. It n value 3. That of A value, how much value given from statement? That of A value 1 by 2 given. In statement, that of A also given if that of A is equal to 1 by 2. Okay, now substitute here 64 times of 1 by 2 power n minus 1, 3 minus 1 whole square, power 4. So 64 by 16, what we get here? 4 answer. From statement, these two are given. So that of A is equal 1 by 2 and 3 by 3 matrix. Okay, now I'm going to explain next problem in the statement that of adjoint of A given 16, then find out that A. Okay, we have that of adjoint of A is equal to that A power n minus 1. Okay, here that A power n minus 1. N value, how much value here? N is equal to 3 by 3 matrix is given. N is equal to 3. 3 minus 1 is equal to 16. 16 can be written as 4 square. So that A whole square is equal to 4 square. That A value, how much value? Square root on both sides, plus or minus 4. Okay, now I am going to explain next problem in the statement. Matrix A is given 1 square, 2 square, 3 square, 2 square, 3 square, 4 square, 3 square, 4 square, 5 square. Two methods are there by using det procedure. Okay, det of adjoint of A, formula is that A power n minus 1. How to compute that according to procedure you should follow. Okay, one more direct formula is there. Okay, we have one formula. Det of A is equal to det of n square, det of n square, n plus 1 whole square, n plus 2 whole square, n plus 1 whole square, n plus 2 whole square, n plus 3 whole square, n plus 2 whole square, n plus 3 whole square, n plus 4 whole square is equal to what is answer? Minus 8 for all n belongs to any natural number. Let us take n is equal to 1. What we get? Det of A is equal to n plus 1 substitute. 1 square, 1 plus 1, 2, 2 square, 3 square, 2 square, 3 square, 4 square, 3 square, 4 square, 5 square. What we get here? This is also minus 8. Okay, what is required here? Required is det of adjoint of A. So det of adjoint of A, we have det A power n minus 1. Det A value minus 8 power n minus 1 means 3 minus 1 whole. 3 minus 1 is nothing but 2. So minus 8 whole square, how much value? 64 answer. Thank you for watching. Remaining questions I will explain next class.